There we go. We are live? I don't know. Who can say? Hey everyone, welcome to Open Space here on Monday. Of course, this is my weekly live Q&A show where I sometimes bring a guest, sometimes it's just me. This week, I'm really glad that I was finally able to organize this interview with Dr. Ryan Watkins, who is a specialist with the moon from the Planetary Science Institute. Dr. Watkins, welcome to Open Space.
Yes, thank you for having me.
So, for people who don't know who you are, can you give us an introduction? Who are you? What do you do?
Yep. Like you said, my name is Ryan Watkins. I work for the Planetary Science Institute. So my main area of expertise is in lunar science, so studying the moon. Specifically, I use remote sensing data to understand surface properties. So my primary data set that I use is on the Lunar Reconnaissance
Right.
Orbiter. So I work with a camera system, and I primarily look at images and study how what the reflectance properties of the moon tell us about different physical and compositional properties.
And it feels like the Lunar Reconnaissance Orbiter has been there forever and
Yeah,
has
10 years. Yeah.
really mapped the surface of the moon down to exquisite detail. I mean, it's quite
Yeah.
impressive how much data we have for the moon at this point.
Yeah, it's amazing, and we're learning new things every day.
Um,
And I imagine we will be for years to come with that data set.
yeah, well, I mean, obviously, when you sort of look at the piles of missions that are in the works right now, both orbiters, landers, and eventually rovers, everything that the Chinese are doing, the potential for, of course, humans to return to the moon, and not just from the Artemis program, but whatever SpaceX has planned, not to mention whatever the Chinese are planning. Like, the moon is now the source of a tremendous amount of research and investigation.
Mhm. Yep. Yeah, that's true. Yeah, like you said, there's several countries are planning to go in the very near future, some in the more distant future. Yeah.
So I would like to just talk about, like, what is our current understanding about just like what are the big mysteries about the moon that you're interested in getting more information on at this point?
Yeah. There's a few kind of I guess key mysteries, if you want to put it that way. Big unanswered questions regarding the moon. Some are larger scale, the moon as a whole. We don't fully know how it formed. There's theories, there's leading theories, but we don't know. We don't know exactly how it formed. There's a lot of questions regarding the bombardment history of the moon, especially the timing of some of the early bombardment and the early lunar history. Did it all happen in what they call a cataclysm, a bunch of impacts all at once, or was it just that over time the number of impacts died down? So there's a lot of things we don't understand about the impact history. One key area that I am interested in is volcanism. So there's different types of volcanism across the lunar surface. There's your typical Mare basalts, which are similar to volcanism we see on the moon if you went to Hawaii or something. There's more rare types of volcanism like silicic volcanism that has materials like granites and rhyolites and things that are actually more rare on the moon. And we don't fully understand kind of the source and the formation and the thermal history of the moon in that regards. So again, lots of stuff regarding thermal history.
So with, I mean, for those kinds of questions, like, still the question is, like, when did the moon exactly, how did it form? I know the leading theory is, of course, that a Mars-sized object smashed into the Earth and splashed out the moon, and maybe it formed in situ at the beginning. Will, like, for example, those kinds of questions, like being able to actually sample the various kinds of lava flows, tell you which formation theory is more likely?
So I'll just preface this with formation theories are not my main area of expertise.
Yeah.
So I'm not going to have all the answers,
Yeah.
but yeah. So samples can actually tell us a lot. They may not hold all of the answers to which of these theories is right about the moon, or is it some that we have one that we haven't even thought of. They'll probably tell us a lot more about the evolution of the moon. Maybe after formation, how did things kind of come to be in terms of rock types and different things. There's a lot of, but there is a lot we can answer about looking at the composition of the rocks. That's kind of how some of these theories came to be anyway, because they noticed isotopic compositions were similar to, on the moon, were similar to what we see on Earth. So that kind of led to the idea of a common origin and this giant impact hypothesis. So yeah, so having more samples with more, compositional data can help, as well as just improved models and different kind of kind of thing. So,
but obviously one of the areas of greatest interest is the presence and quantities of water on the moon. So how much water do we currently think is located on the moon, and where?
yeah, I'm not going to have a number for you just because it's not water's.
How many Olympic
It's
swimming
not what I think
pools?
about every day. And if I give you a number, it's going to be wrong.
Yeah,
So
yeah.
I think that's kind of one of the questions we're still looking at. Really, is how much water, because we don't fully understand both the vertical and horizontal distribution. How deep does it go? How spread out is it? We kind of know, if it's there. Well, it is there, but it's going to be primarily at the poles because those areas are colder and they can retain water and ice. So we don't fully know like what form it's in or how deep it goes. So I don't think we even really know exactly how much is there. We do think it's a large enough quantity that we can go there and we can use it, and humans can survive, and we can, make things like rocket fuel. So it's not,
A better answer on that.
there's a few things. Right now it's all orbital data that's given us or mainly orbital data, I should say, that's given us evidence for water and water ice. So what we really need are some surface missions, missions that can go to the polar areas and really start to take measurements in situ. These can be robotic or manned missions, things that can help start prospecting for resources and really kind of measuring, okay, maybe how deep does it go? Maybe we need some radar or something that can give us information about what's under the surface, and even more targeted orbital missions that just have, the right kinds of instruments that can look for these signatures and really target that. So there's the surface and the orbital approach. It's just, more data that we need.
And I mean, I know that there are various missions that are in the works right now. There's, when do you think we'll start, like by 20? I mean, I know all timelines are up in the air at this point, thanks to a certain worldwide event, but which we dare not speak its name on YouTube, lest we have our video shunned. But what, are there any like specific missions in the works that maybe people should be keeping their eyes on that are going to be the one that will be like, okay, we're waiting for that mission to fly because it's going to give us that next level, like the way people are waiting for James Webb, right? Or the way people are waiting for WFIRST. What, is there anything specifically that you're quite excited about that we should be keeping our eye on?
Yeah. If you want to talk in terms of water ice specifically, the big one to keep your eye out for is it's called Viper. So it's a NASA funded mission. I don't remember exactly what the acronym stands for, but it's basically going to prospect for resources.
Volatiles, something. Yeah.
Resource prospecting.
Yeah.
But so it's going to be not an orbiter, sorry, a rover. And it's actually going to launch on one of the CLPS providers, the commercial lunar payload service providers. So it'll be a commercial lander that will take it to the moon. And actually right now they're kind of in the middle of essentially bidding or writing proposals to see who will carry this rover. So we don't actually know who's going to take it yet. I think the timeline they're targeting is 2023, last I heard.
Okay.
Plus or minus a year maybe.
Yeah.
But yeah, so that one's going to have different instruments that can essentially measure, what kinds of resources and volatiles and things like water and oxygen, hydrogen and things like that are on the moon. So that's kind of the big one that's really been in the works to keep an eye out for. I'm not really sure if any of the international missions are going to have those kinds of things, but everyone has their eyes on the South Pole. So really any mission that's going to go to the South Pole, you're going to just want to keep your eyes on because any of those are going to be looking for water and water ice.
And so with the South Pole, I mean, thanks to I think it was the Chandrayaan mission originally gave those first indications of water, and other follow-on observations have really proven that case now. I mean, how useful, it's kind of tough because we sort of like, on the one hand, we just are interested in scientific questions, right? Like, is there water? Where did it form? How did it arrive? How long has it been there? Where is it going? What's happening with the water? But then I think there's this whole other field, which is about like, can we use it? How hard will it be for us to use it? So I'd like to kind of address those as sort of two separate threads, take off the lunar, the prospecting hat, and just sort of from the science side, how do you find this story of water fascinating, and what are you hoping to learn from it?
Yeah. So, even some of the stuff you just said answers that question a bit. Like it's fascinating because how did it get there? How long has it been there? is it just, part of the moon? Was it brought in by cometary impacts? What, like, how did it get there? I think we're fairly confident, based on the measurements we have, that it is usable. There's a lot of people who've been working on ways to extract things like oxygen and the water and stuff from the regolith, and actually use it. So kind of what interests me is that, just the fact that we can take this water, sorry, and use it to support human life, to potentially create rocket fuel, because, rocket fuel is hydrogen and oxygen, and we can get those things from the lunar regolith. So being able to launch spacecraft off the moon, I think it's just, being able to use these resources, not only from a scientific perspective of knowing how they got there, what this means for the history of the moon, but just like what it means for the future of us living on the moon.
Yeah. Did you grab some water? Are you okay?
Oh yeah, I got some right here.
Okay. Okay.
Thanks. Yeah.
All right. Yeah, that's a rookie mistake. I sort of like, a couple of times I've forgotten water, and then I was like,
yeah.
So then, so let's talk a bit about like where some of this water might be positioned. So, there's the lunar that's mixed in with the regolith. There's also the water that is mixed in just with, or that could be like actual deposits, right?
Yeah. And again, it's not something I know a lot about, but yeah, I think that's kind of a question to be answered is, how much of it is, it's most likely mixed in with the regolith that's there. To what extent, I don't know that we're going to dig and find an ice block per se. It's probably just, these permanently shadowed areas that are very cold, that just really allow for the water to remain there without, evaporating or going anywhere.
Yeah.
So it may be in the rocks. It's probably likely just mixed in with the regolith.
And then what is the process that you would actually be able to utilize that water for, for your rocket fuel, for your breathable atmosphere, whatever?
Yeah, I don't know that I'm going to have an answer for that, just because it's not what I.
Yeah.
Developing those systems, but yeah, there's a couple things that I've kind of seen through the years without having a lot of details of, just different extraction processes that people are working on to grind up rocks and essentially grab these different chemicals from them, or elements, the water, whether it be water, oxygen, hydrogen. A lot of it's going to just depend on grinding up rocks and using different systems. So I really can't tell you much more than that because I don't develop them, but there are lots of people working on it. It's a big area of study in our field.
Well, the thing that I've found quite fascinating recently is that up until this point, it was really felt like the inner solar system from Vesta inward is dry as a bone, that there's just no volatiles at all. And the story really seems to be now more so that, in fact, just below the surface, there are volatiles, a lot more than anyone was ever anticipating. And so that alone is kind of a fascinating, again, you wear your two hats. Like on the one hand, you've got your science hat and you're just kind of saying like, how come, why, and what can we learn about the story? If those volatiles are there, we could learn a tremendous amount about just the history of the solar system. Mm-hmm. But if they are, then you put on your hat and you say, wow, you could just grind up a medium-sized asteroid and now you've got volatiles. And so you don't necessarily need to go down, and tear up the moon for those purposes. But, from a practical sense, isn't it like way harder than anybody thinks?
I think probably yes. Again, without knowing all the details, it's not an easy thing. I think if it was, we probably would have been doing more of it by now.
Yeah. But I know you've been working. I believe you had been working with Blue Origin. Are you still working with Blue Origin?
Yeah. So I am on Blue Origin's Science Advisory Board for their Blue Moon Lander project. Yes, I'm still on the board.
And so I would, without necessarily revealing too many details, what kind of information do they need from you?
Yeah. So the things they're kind of interested in from the Science Advisory Board are, there's several things. Primarily, they want to stay up to date on the scientific questions that need to be answered. Now, they're not necessarily looking to deliver their own scientific payloads. They're going to have customers that will pay to have their payloads sent. But that being said, they're going to need to select landing sites, and you want to make sure you pick landing sites that are of scientific value. Honestly, anywhere on the moon, you're going to learn something. So they're all valuable, but They're coming to us, wanting to know like, okay, where are the places that we should land and we can feasibly land? And then they're just wanting guidance on things like, payloads and payload capacity, what kinds of payloads should we be looking at? How should we get them to the surface? How can we mitigate issues like dust, because that's a big problem.
Yes.
Yeah. So they're coming to the scientists just looking at, it's always good. You got to have scientists and engineers working together. So they want to know, okay, what are you guys interested in? And how can we make that work with this design? How do we need to change our lander design to accommodate things that scientists need in terms of, power systems and thermal systems and things like that? Yeah.
Well, you must have poured over thousands of pictures from the Lunar Reconnaissance Orbiter. So if there's some place that, there's some places down on the surface of the moon, some specific places that you've sort of traveled to with your imagination that you would love to see from the ground specifically?
Yeah. I mean, I have a few favorites. One that's kind of, I guess, been closer to my heart in the last few years is this place called Aristarchus. There's both a plateau and a crater. This whole area is there's just so many interesting things. There's the crater itself may have excavated some of these silicic volcanic materials that I mentioned earlier. So these like granitic materials, rhyolites. There's a lot of different types of volcanism in this area. On the plateau, there's pyroclastics, which are explosive volcanism products. It's also right next to possibly some of the youngest volcanics on the moon. So if you can get there and like have a rover, just the stuff you can learn in terms of volcanism alone, and that's not even addressing any other areas of science that you can learn about the same area. There's just so much. The samples we could take, the data we could get. You could learn a lot about, even volatiles in the pyroclastics, because they tend to retain volatiles within the glass beads that tend to be produced there.
Right. Well, so, I mean, we're fairly familiar with, say, like the Curiosity rover, and we've all seen pictures and we've seen its selfies and stuff. How would a rover crawling around the moon be different from what we are familiar with Curiosity?
Yeah, it'd probably be different in a few different areas. The regolith on the moon is obviously different, so it may be that it needs to be designed differently to drive on a different terrain. Driving on the moon, in some regards, could be easier because we don't have windstorms. We don't have stuff like that to worry about. The bigger thing you really need to worry about driving around the moon are, first off, craters. There's just so many of them. But once you're on the surface, if you got the right kind of navigation tools, should be easy enough to get around those. But surviving the night is the biggest issue, because of the temperature extremes. So you've got to have the right kind of, power and thermal systems to keep your rover alive overnight, and then hopefully wake up again on the next lunar day.
So can we talk about that for a second? Like what kind of extremes? Like if you're an engineer and you're being told what the criteria are that you have to design for, how tough would it be? How awful is it?
Yeah. Goodness, I'm not going to remember the exact numbers. I want to say, and somebody out there may correct me if I'm wrong, is something like 400 degrees Celsius difference between the two extremes. Maybe it's 300, 400. It's a big temperature swing.
Yeah.
Enough that you need to be concerned. It's incredibly warm during the day. There's no atmosphere shielding you from the solar radiation or anything. So then it's very cold at night when you're obviously not in the sun.
For 2 weeks.
Yeah, and it's 2 weeks long. Yeah,
right.
Yeah. The day and the night are both 2 weeks long. So it's not like you just got to survive for a few hours and then you wake up and keep on going. Yeah.
Yeah. And I mean, we look at what ended Spirit or ended Opportunity just in the last couple of years, that the big dust storm came in and it had solar panel reduced down to some fraction of its normal solar input, and it couldn't keep its internal temperature warm enough, and it couldn't keep its electronics going, couldn't recharge its batteries, and it died. Mm-hmm. That's a paradise compared to what a lunar rover is going to have to deal with, because it's going to have to be keeping its electronics going, for 2 weeks of frigid temperature, colder than Spirit ever or Opportunity ever went through, and then on the flip side, hotter than anything Opportunity ever went through.
Yeah, but at the same time, the Russians did it in the 70s, so it's not impossible.
Right.
It's just you got to have the right design. It obviously makes everything cost more and makes it bigger and more complicated, but yeah, it's not impossible. It's just tough.
Yeah. And then of course the regolith itself, I know, is incredibly gritty. Like this stuff is very very hard on your electronics. So have the rovers that have already done their work, did they fail because, due to like, were they able to see what kind of problems they were having with its actual regolith?
Yeah, from the things that I have, read or seen, I don't know that I've seen that they really had massive issues because of the regolith. I think some of the Apollo, the lunar rovers that they kind of drove around, they kicked up a lot of dust, but none of them failed because of dust, as far as I know. I think the Chinese, the U2 rover, I want to say it didn't survive the night, but I don't remember if that was the exact failure mechanism. Um,
The
it
the
was a while ago now.
the YouTube, the first one, not the second
First
one.
one, yeah, the
Yeah,
second one's going.
yeah,
It has also survived the lunar night.
yeah.
But no, from what I've read, I mean, yes, the dust is an issue. The regolith on the moon is pretty compact, so in terms of driving, I don't think there's a lot of issues. It's more yet if it gets lodged in your mechanics or your instruments, those are things to worry about. But from what I can remember, I don't think any one of them has actually, failed because of the dust.
Right.
But still something you have to think about because
Yeah,
it is.
just don't breathe it.
Yeah, you don't want to breathe.
Yeah, well, it's interesting though. I mean, we had Phil Metzger on a couple of weeks back, and we were talking about just some of the work that he had done, just in simulating how the dust gets sprayed up into orbit when one of your rockets comes down, and it can actually damage other spacecraft that are attempting to land, roughly the same time as you. Like, I mean, every place seems to have its own interesting challenges. And you talked about the temperature difference, and of course there's the regolith. There's the lower gravity. Is that helpful, harmful?
Uh, um, yes.
Yeah.
Yeah. So I guess it probably depends on what scenario you're looking at. Yeah. So in terms of a rocket exhaust landing, for example, you don't have a lot of gravity pulling that dust back down, which is both good and bad because on one hand you kind of want it to come down so it doesn't hit other things. But on the other hand, it might kind of shoot it farther away and maybe I don't know. Yeah, it really just depends on what you're talking about. Yeah, because one of the bigger issues I think is some of the electrostatics because of the lack of atmosphere. It's not really related to gravity per se. These day-night swings charge the dust, and that kind of will cause it to loft and things as well. But yeah, the gravity question is interesting. I think it just depends on what you're looking at in terms of the dust. Yeah.
Yeah. Have you looked into these fascinating lava tubes and the sort of caved in roofs of these lava tubes?
I haven't done a lot of work with them personally, but I'm familiar with them and some of the work that's going on regarding the lava tubes. Yeah, they're of interest for a few different reasons. First off, we don't know how expansive they are underground. So that's one thing that different people are looking at. They're of interest as a potential habitat type area for humans because they're shielded from radiation and micrometeorite bombardments and different things like that. Yeah, they're definitely interesting features. Again, that I don't study a lot about them, but get down in one of those, you can actually see the different layers in the regolith and learn some about the history of the things that were deposited there, whether it be impacts or volcanics or different materials. But they're definitely fascinating. I find them very interesting.
Yeah, yeah. And then one of the other things that I found really interesting was apparently the Chinese lander did have a ground penetrating radar on it. It was able to map out the depth of the regolith underneath it. Did you read that paper? Was that a surprise to you? How much
I don't remember if I read the paper. I do remember seeing the news about it.
Yeah, like dozens of meters deep of regolith. Like it just went on and on and on. Like
no, it didn't surprise me. Just mostly because I'm in the field and I kind of knew that it was
deep.
Pretty dense.
Yeah.
And just like if you think about the moon's history, it's just been bombarded for millions of years, and it's just impact after impact building this regolith up. Yeah, I mean, it's we need more ground penetrating radar because I think it's really interesting to figure out how deep it is. Yeah.
Yeah, I mean, when we look at the pictures of the moon from our telescopes and even from the Lunar Reconnaissance Orbiter, and when you see like the bottoms of those craters, they just look like these beautiful, perfectly smooth, almost like fluffy snow-like conditions. And yet, of course, when we saw the astronauts walking around on the moon, but I'm just imagining just billions of years of impacts throwing out debris. And of course, us learning that if a rocket can kick that debris into orbit and have it land on the other side, it's like it's constantly snowing lunar debris on itself.
Yeah.
From everywhere all the time, and just building up and building up and building up. And
yeah, that's really interesting. I've never thought about it that way, but yeah.
That this stuff is, like
Moon is a dusty place.
yeah. But just the fact that an asteroid can hit on one side, the debris can fly up and then end up on the other side of the moon because can be following some kind of parabolic trajectory. And
I think the thing that always gets me too is just even with rocket exhaust, there's particles being ejected out of lunar orbit, reaching escape velocity. That's just, it's fascinating to me. It's, obviously a dangerous thing as well, but it's just very fascinating.
How we talked a bit about the state of lava. How seismically active do we think the moon is at this point?
Yeah, so the moon's not seismically active in the same sense that you might think of the Earth being seismically active. So, on Earth, we obviously have earthquakes produced when, the plates are moving and different things. But the moon doesn't have plates or plate tectonics. Any seismic activity you get from the moon is from, one of a few different sources. We have I guess, what do they call them? So basically the stress on the moon from different thermal stresses can make it contract and expand. And that can give you some seismic activity. Even some of the seismic data from Apollo, which is from impacts, actually generating shaking within the moon. We actually don't have a lot of data about, I guess, the seismic activity of the moon. Again, it's not plates, it's more these internal stresses. So there are a lot of people who are looking to try to get some more seismometers on the moon to answer these questions, because we had them on Apollo and we had a few, but they were cut off after the Apollo missions. And we really need more kind of global seismic data to really know how much moonquake activity is happening.
It's funny, like the InSight lander that's on Mars right now, I'm sure that would be a wonderful lander to have on the moon as well to answer similar questions. If we can get a seismometer that sensitive onto the moon to be able to see it. But so it's more like, like we know that Mercury, for example, is contracting and as it's kind of cooling down from its formation, and that it's caused weird jumbled up terrain. And so you're getting this, the moon is still cooling down to some degree.
Yeah. So again, like I said, it's the kind of these temperature swings, the internal stresses. I think there may be, again, with it being a little bit outside my area of expertise, some of the tidal forces even that experiences with Earth.
Right.
Just like push and pull on the moon. Yeah, you get. We don't get, again, we don't get like earthquakes like we do on Earth, but there are different surface expressions of this, contracting and expanding of the lunar surface. So there is seismic activity. It's just different.
How much do we know about the far side of the moon?
Mm-hmm. We know a good bit. Again, we don't have samples from the far side. Well, we don't have samples where we know exactly where they're from. We may have some far side samples in the meteorite collection, but
we talked about that earlier.
We can't really say where any of those are from for sure.
Yeah.
We don't have any samples, but we do have a lot of orbital data, and that's really where we get kind of the majority of our information about the far side in terms of the composition of the crust and how thick it is. It's thicker on the far side. There's a lot less volcanic activity on the far side. So there are a lot of unanswered questions, again, because we haven't been to the surface, with the exception of the Chinese mission that's down near the pole that is on the far side. But yeah, it's largely unexplored, but we know probably more than maybe a lot of people realize, but there's a lot to be learned.
But the far side looks remarkably different, as you said, less volcanic activity. Really, we see it's just all craters on the far side without those mare that we see on the near side. So what at this point do you think is the cause of that?
We don't know. I'm sure there are some theories. I don't have, a favorite or anything, but that's kind of one of the big unanswered questions in lunar science. Is we call it the dichotomy. Why is the crust thicker, on the far side, and why is there less volcanism? And again, there are a few theories out there. I'm not well versed on most of them, but it's what we don't know.
So then, if you could wave your magic wand, what would be the evidence that you would like to collect that would help you get closer to that answer?
Yeah, I think if you almost any like lunar scientists you ask, they say samples. We just
Yes.
need more samples.
Right.
You know, they tell us about the composition, they tell us about the history, they can tell us about the depths from which they came, and really tell us a lot about the internal structure of the moon and the activity and the different things that helped lead to its formation. Um, Trying to think, you know, anything that can like give us information in terms of the timing of the volcanics, the timing of the impacts, especially the big basins that really reshaped the moon. We'll really just start to answer a lot of these questions. It's going to be a lot of, you know, it's a puzzle. There's a lot of pieces you got to grab at, whether it be samples or
Right.
like, you know, data regarding the internal structure. So, you know, more this radar type data that can tell us about, you know, how deep everything is and what the internal structure is like. I just think there's going to be a lot of different pieces you got to put together to really answer the question of what's happening.
Yeah, we covered a story actually here on this channel about a year ago, talking about this sample of the Earth that was found on the moon and brought back from by the astronauts.
Mm-hmm.
That, and you can think about this complex series of events where some object smashes into the Earth, the rock lands on the moon, and then multiple impacts bury this sample down deep on the moon, and then other impacts dig it back up. And then we talked about this earlier about how potentially you've got an impact and then samples are being thrown. You pick up a rock and you think, oh, you know, this just came off of that shelf over there and has just landed on the ground, but it could very well have traveled from literally the other side of the moon and
Yep.
then plunked down on the surface. So like many, like you say, you seriously want a lot of samples.
Yeah, and you're gonna need them. I mean, okay, one good example is Apollo 12. It landed on the ray of Copernicus crater, and so which was not necessarily close to the landing site. It was a good deal away. I don't know how far exactly, but that's one reason we think we know the age of Copernicus is because of these samples that Apollo brought back, Apollo 12. But yeah, so you know that is one thing to think about when you land on the moon. You could very well be landing in the ejected debris of a crater from the other side. So
Yeah.
you know you got to be strategic. You definitely when planning samples, and you need, yeah, like you said, more than one
Yeah.
because
I mean, I sort of imagine like a geologist walking along the side of a hillside and they find a rock, and each one of these rocks has a story. Where did it come? Where did you come from? Right. And you're like looking around, you're like, oh, there's an exposed granite half a kilometer up, and it must have come rolled down the hill and got
yep,
here from there. But if there's no granite around, then there's some other story. Oh, there used to be a river here or whatever, right? And so that same, I can just sort of imagine that same fascinating, almost detective process with every single rock. You have a few hundred kilograms of samples that were brought back from the astronauts, I don't know, like 1,000 years ago. Uh,
it feels like.
it feels like it. I know. It's like these rocks again. Uh, do you think that there's going to be a bit more of an industrial scale of sample return this time around? Are you
um
pitching for that? It
it,
sounds like you really want samples, is what
I
I'm
can
hearing.
definitely tell you that lunar scientists are pitching for it. The last I heard, and I'm not like, you know, like directly involved in the Artemis program per se, so I don't know all the inner workings and plannings at the moment. The last I heard, I don't think the sample volume was actually that large. I don't think it was even larger than Apollo, you know, for the first mission at least. But it is one thing that lunar scientists are pushing for because, I mean, if you think about the Apollo samples, it's been 50 plus years now and we're still learning from them. We still haven't even opened some of them. You know,
Yeah,
that's kind of the big thing that's
incredible.
happening now. So, and which was a strategic planning on, you know, the Apollo scientists and engineers part of, you know, waiting to open these till we had improved technologies. And I think we're going to want to do the same thing. We're going to want to bring a lot back. We're going to want to look at a lot of it now. We're going to want to hold on to a lot of it for, 50 years down the road again when we maybe have different ways to analyze it. So yeah, so I think there's a lot of reasons to really advocate and push for large sample volumes. Like again, and you just said, this each rock has a different story. So you don't want to just get one or two rocks or, just 1 or 2 kilograms. You're going to need a lot more than that to really start to piece things together. Yeah.
Yeah. And so I'm kind of imagining either whether it's people or whether it's some sort of rover doing sample return, and you also want core samples, and you also want you want to dig down multiple meters into that regolith and pull back up a big core sample and bring that home. And tear that apart and see what's inside. Yeah, absolutely. So I got a couple of questions. Well, Larry Beckham, Larry Beckham is asking, is your job essential at the time? How has this situation changed the way you do your work? I'd be interested to know, as someone who is involved in various missions at various stages, how has the event influenced your sort of day-to-day activity?
Yeah. So my, I don't think anyone's out there saying my job is essential, but
Yeah.
my job, like particularly, I actually am a remote worker 100% of the time. So I work remotely for my company. Everything I do is on a computer, and data comes to the spacecraft. So in terms of like what I can do, that has not changed. I can still do all the same research I was doing. The only thing that is different is now I'm home with 2 kids and a husband, and so it's more of like, when do I have time to actually do the work?
Yeah.
But yeah, so no, I've definitely gotten lucky in the sense that my research, my grant money, none of that has been affected. So
Yeah, my life has changed not at all.
yeah,
I broadcast from the same location. I manage, my team has been remote for the entire duration of this. So, um,
I'm just on Zoom a lot more than
yeah,
anything else.
I know it's made, and that's the joke that I keep making every week is that, everybody is so much better trained on Zoom these days. I have much less technical support to bring my guests on,
I know
which,
where the lighting is best in my house
yeah,
now.
exactly. Yeah. Yeah. They've worked through a lot of their security issues. Things have become markedly improved.
Yep.
Um, so Johnny Wednesday is asking, is there a statistical difference between the near and far sides in terms of number of craters?
Yes. I don't have a number for you,
Right.
but primarily yes, because if you look at the near side, you'll see all of the old lava flows, the Mare basalts. They're a lot smoother. They're a lot younger, so they are just have fewer craters on them because they're younger. They haven't been exposed as long, and because that is such a large part of the near side of the moon. There's obviously fewer craters. Yeah, the far side has a lot more
But
craters.
but do we think that the near side was hit by less craters or hit by less objects, or it was just resurfaced and so that
I
evidence was hidden?
Yeah, I'm pretty sure it was just resurfaced. I don't think one side was exposed more than the other. But that being said, we are, you know, tidally locked with the Earth, and so you have, they're not exposed to the same part of space all the time. So it could be that impactors that were coming in could have hit one side more frequently than the
Right.
other. I'm not sure if we know 100% for sure because there is the extensive resurfacing of the near side, so it's hard to say.
Yeah. Yeah. And so it might be that impactors that were going to come from the Earth side were gobbled up by the Earth instead.
Yeah, yeah.
I mean,
You do have this, asteroid eater right there too.
yeah,
So
yeah. It's always fascinating to think about that when we look up at the moon or when we look at the moon in a telescope or pictures, whatever, we just see this obliterated surface. The Earth must have been worse,
oh yeah.
right? Until it's its plate tectonics kicked in or in all of the resurfacing that's
Yeah.
gone on. I mean, we're a bigger gravity well than the moon is.
Yeah, and then that's one reason why a lot of people are really interested too in the kind of bombardment history of the moon, because it tells us a lot about what Earth went through. We're not just in it for the moon all the time. There are a lot of questions that'll tell us about what was going on in the whole Earth system as well, or the whole inner solar system for that matter.
Yeah, yeah. Um, Arjun is asking, is the moon less differentiated than the Earth since it's so small? Are there more metals on the surface?
Um, oh, metals. I am not a sample person, so I'm not going to try to talk about metals. But yeah, so there it is, somewhat less differentiated. If you just look at rock types in general, there's a lot fewer. We don't have, there's not old, water flow, oceans, things like that, creating sedimentary rocks or anything. It's primarily, like volcanic rocks and the crust of the moon that was formed early in history. So I'm going to go with yes, but I don't know that I can really expand upon a lot of the
Right.
other more specific
I mean, we
questions.
know that there's a lot of really interesting metals that are bound up with the regolith in the rocks itself, like titanium and
Yeah,
aluminum and
yeah,
iron
we have iron and all
and
that.
things
Yeah.
like that, but not necessarily the the kinds of deposits. I mean, again, I'm not a geologist, but
Neither am I.
but but we find, but we find like various amounts of like various kinds of metal and stuff can actually be caused by activity that happens on the Earth that's different, like having the water, as you said, having sediment, etc., that can create some concentrations of some of these
Mhm.
kinds of materials that we see here on Earth.
Yeah, yeah, and we definitely, have areas where some basalts may have higher titanium or lower titanium or higher iron. Yeah, yeah. So
Yeah.
there's differences there as well.
Aaron's is asking, do people on the moon use time on Earth like 24 hours? How do you think that people would count lunar time if there was a base there?
Yeah, I'm not 100% sure what the Apollo astronauts did, but I imagine we would, count it very similar. We think of the lunar day, we call it a lunar day because, for the moon, that is one day, but for us, it's 2 weeks. So yeah, I think, if we were living and operating there, we may, operate on a similar time scale. I mean, who's going to want to count however many hours are in 2 weeks every day? But yeah,
Yeah.
interesting question. This is something that we'll have to figure out before we want to be there long term.
Well, I know like the people who work with the Mars rovers, they had to deal
Yeah.
with this situation. They had an extra of however half an hour a day or whatever that they had to deal with, and so each day they had to um, focus on their shifts would move following Mars
Yeah.
time, and eventually they're
Yeah.
working in the middle of the night and going home in the day, and then
Mhm.
eventually they gave up and went back to regular Earth time, and just sometimes different people were
It's
able to
weird.
work on the rovers. Yeah.
Yeah, yeah. And if you think about it, we haven't had a human presence or even a lander really presence on the moon that's lasted more than a lunar day from the US side. There's been Russia and China. So yeah, there's a lot of operational things we'll have to figure out when we do have a long duration mission.
Um, Sean Marston is asking, can you talk about the possibilities of mining helium? I'm sure you've heard this a million times, mining helium on the moon as we're running low here on Earth. Again, I mean, how much helium is really there on the moon?
Yeah, that unfortunately that's not something I really know the answer to. I know it is widely discussed, and it is most likely present, but I don't know how much or how feasible it is to get it. Yeah, it's kind of not something I've really
Yeah, it's
dug.
fairly low. Like I forget the numbers. Is like you'd have to like chew up an acre of regolith to pull some
Yeah,
concentration.
it's not like you're just gonna land somewhere and helium-3, I found it. Yeah,
Yeah,
no.
exactly. Yeah, yeah.
Yeah,
Just jam that into the fusion
yeah, yeah.
reactor and away you go.
Mhm.
Um, uh, what about solar flares? Arjun is asking about solar flares. Do we think about how bad solar flares are on the surface of the moon?
Uh, that's a good question. It is something to be concerned with because again the moon doesn't have an atmosphere or really a whole lot of anything protecting it from solar radiation. So yeah, so especially when we want to send a human or even a rover for that sake to the moon, yeah, there's things to think about in terms of radiation exposure. Yeah, and I couldn't speak necessarily to how much more significant a solar flare is going to be than just prolonged solar radiation. But yeah, it's something to think about.
Yeah, I mean, we know that the moon doesn't have a magnetic field, but there's something going on there. I mean, there's some pretty interesting features on the surface of the moon, like I don't know if you've seen the lunar swirls. There's
Oh yeah.
these, yeah, so there is some kind of localized magnetic activity, but not enough to protect you from,
Yeah.
just
Yeah,
enough to
if
make
you're
life
in one of these
interesting.
swirls, like maybe, but yeah, it's very small. There's no, yeah, like you said, no global magnetic field. Yeah.
Yeah, yeah. But again, I guess, do we know if it had one in the past?
I think that's again another kind of
Needs
unanswered
more
question.
samples,
If we
please.
have global, yeah, yeah, yeah. A lot of
Yeah.
people looking into that as well.
Um, uh, so use Nord is saying, could there ever have been life on our moon?
I'm gonna go with no. We've not seen even like the slightest hint of evidence, and the whole, lack of really water atmosphere. Yeah, there's not a lot of things that would really support any kind of life that's gonna enjoy being there.
I
So
mean, even like we think that maybe Venus was better
mhm.
earlier on in the solar system's history. We think that maybe Mars was better early on in the solar system's history. But I mean, with the moon, with its low gravity, it
Yeah.
just can't hold an atmosphere,
No,
right?
and it was molten in its early history. It was volcanically active. It was just not. It's never really had the right conditions for any kind of life. Yeah.
Yeah. One thing that I found that was actually pretty interesting was, we always talk about how the moon is slowly drifting away from the Earth, and apparently it went through a lot of that distancing fairly early on in its history. It's not like a smooth
Yeah.
drift away that people think. It actually did the bulk of its drifting away and then has been slowing it down. So it was, you know, however many million years ago it wasn't that much bigger in the sky. Roger Wilco asks, have they ever tried growing anything in lunar regolith?
Yes. I don't know all the specifics, but actually the Chinese mission that's on the surface now, Chang'e 4, they tried growing something. I'm not sure what the status of the end result of that whole
Yeah,
experiment.
it worked. They had they had a tiny little greenhouse, but I don't think they were using regolith specifically, but they had a
Okay.
tiny little greenhouse and they grew like four different plants, and then
Mm.
when the lunar night came, they all died.
Okay. Yeah. Yeah. Okay. Yeah. So maybe those may not have been in the regolith per se.
Yeah.
I know there's been other people who've done experiments growing plants in like kind of Martian simulants and things. I'm sure there's been something in lunar type simulants or similar conditions. Again, I'm not well versed on what happened there, but
Yeah.
I'm pretty sure it's something that has been looked at. Yeah.
Yeah.
And will
Um,
continue to be looked at.
um, Corey S is asking, what's the smallest rover that you could land on the moon? Better have wheeled, walker, jumping, flying? Are there?
Yeah. That's a good question. I don't know, a number for you in terms of size or anything, but there's a lot of different scenarios, that have been looked at. And with the moon, having lower gravity, you can't go too small or you're not going to rove, but you can still go pretty small because it's not impossible to land there. Um, and there are a variety of different types of, rovers or hoppers that have been proposed. Most things have been, slightly larger scale. You think of, the Mars rover, Spirit and Opportunity. We've driven things similar size on the moon. I don't know that we would go much smaller, just because you generally want to take a lot of instruments with you if you're gonna take the time and effort to go there. But that being said, there's a lot you can do with a small rover as well. Maybe you just want a ground penetrating radar and a camera or something. Maybe you're just doing some prospecting and only need a
Right.
few instruments. Yeah,
But
you can go pretty small.
but it's more like, I guess it's more about the launch mass and what you can
Yeah,
fit onto your rocket, and less about how it's going to perform
yeah.
once it arrives there.
Mhm.
I mean, there would definitely be some engineering differences to have a
Yeah, that
rover.
comes down a lot to engineering. Then yeah,
Yeah, yeah. But like, if you've only got 200 kilograms that you can put on top of your Falcon 9 rocket, that's all you've got.
yep, yep.
And then however big a rover that turns into is
Yeah, because you got to have the lander and then the rover. Yeah,
right.
think about. So yeah, you can send a pretty small little rover there. Yeah, like you said, it's a lot of it comes down to engineering and launch, and scientific objectives at some point. Yeah.
But of course, we have seen SpaceX talking about how they may want to be able to, say, take Starship and actually land on the moon. And of
That
course,
terrifies me. Yeah,
that terrifies you.
yeah,
With
just
with
because it's so big. Yeah.
But think of all the samples.
Yeah, well, so it's funny you mentioned having Phil Metzger on a few weeks ago. I actually worked for him for several years, and we do similar research in terms of blast effects. So that's the part that scares me. It's not the why we're going or what we're going to do when we're there. It's the actual landing part because there's just so much dust.
Yeah.
Yeah, that part of it makes me a little nervous. Yeah,
I think, before we did that interview with Dr. Metzger, most people weren't familiar with this problem. I wasn't to that extent, and it was quite a fascinating. People could sort of see it dawning on me as he was talking about the scale of this problem, and I was just like, "Oh no, yeah, that's awful." That
it's a problem.
And it's a gigantic rocket that's going to be blasting a tremendous amount of propellant down onto the surface and kicking the stuff all everywhere, and
Yeah,
making,
well,
and you just like grind away Lunar Reconnaissance Orbiter just into dust as
yes,
it's,
no, please let's not do that.
or at least, smashing up the camera system or whatever.
Yeah,
But think of all the room for,
yeah. Well, the samples would be back. That'd be
you could bring a
great.
lot of metric tons of samples.
Yeah.
Um, I mean, people always ask the people versus robots
Mm-hmm.
argument.
Mm-hmm.
Do you have an opinion?
Yeah, no, I think there's value to both. I do, feel pretty strongly that humans are more efficient. There's a lot of good reasons to send humans instead of a robot. Primarily just because of the real-time decisions you can make. If you think of a geologist in the field, a geologist could pick up a rock and say, oh, this is what it is, and maybe it came from over there. If you have a robot or a rover doing the same thing, looking at a rock, you got to take a picture and then like maybe brush it some and like send the data back and wait for the people to look at it and then tell you like, okay, maybe then drive over to this rock. And the process just takes a lot longer. There's a lot more science you can do in a short period of time with a human. That being said, there's still value in rovers. There's a lot rovers can do with their instruments. But there's just humans can do a lot more quickly.
Yeah, yeah. I mean, I think there's some pretty interesting hybrid concepts out there at this point as well, though. Like, I know that Luca Pomertano operated a rover on the surface of the Earth from the International Space Station. And you could imagine these sort of combinations where you do have, say, a geologist that's on the Lunar Gateway operating a rover very quickly, almost in virtual reality. And they really are. They've got, nimble little arms and they're picking things up and they're examining them and brushing them off. And they don't have to go down and experience the actual surface of the moon. So
yeah, that's definitely something that's been looked at. Is just kind of how humans and robots can kind of work together, whether it be a human on Gateway or elsewhere driving a rover. I'm actually going to be doing some field work later this year. It was supposed to be this month until things happen.
yeah, apart from the
But,
event. Yeah.
yeah, the event. So I'm part of a survey team. It's a Solar System Exploration Research Virtual Institute. And one of our objectives is actually to take a rover in the field, and we're going to test a few different things, an autonomous rover and then a rover that's, somewhat assisted by human. We're going to have scientists driving it in a back room. And then at some point we're going to have humans in the field helping the robot or the rover. Just, looking at the performance and the functionality, with these different scenarios, whether it's working independently or working with the assistance of humans. Yeah. There's a lot of different scenarios to look at.
It feels like, I mean, we've really gone through this revolution of machine learning at this point. I mean, here we are, a computer can beat anyone at a game of Go or chess or StarCraft or recognize whether something is a cat or not a cat or make a picture of a person or whatever, right? That kind of technology seems like it just has so much value for these kinds of autonomous rovers. Is that, are you guys getting a chance to work with that kind of machine learning with these rovers?
Our team, I don't think we're going to do any machine learning. I'm not sure if others are, but machine learning, like you said, is kind of a big, thing that's really becoming really useful in our field. And I actually haven't seen a lot about how it's, maybe working together with like rovers and data that's being taken in the field, but like, I'm sure that is something somebody's thinking of, and will be very valuable in the future. It's really valuable now just for working with large data sets from, orbiters and like LRO right now. So could very well be applied to rover data and analyzing that. Yeah. It's
Yeah.
gonna be very.
I mean, you sort of think about all of the separate pieces and that you could have a rover that is able to navigate autonomously over some chunk of terrain. And then you also think about a rover that's designed, or some kind of imaging subsystem that's designed to recognize different interesting geological samples. And you mash the two together and you've got a rover that's scampering across the landscape, finding interesting rocks and sticking them into its collection bag and moving and then bringing him home to some very reasonably sized sample return. So
that's actually one thing similar we're going to be testing on our rover is kind of a software package that's been developed to take this kind of data in the field and like, okay, what kind of rock is this? And then
and ask the robot,
so it's really
robot, what is this, right?
Yeah.
And so the question is, can you teach a robot to make a guess on what a rock is better than you can teach an astronaut?
Yeah.
Because there was that I don't know if you ever saw that, was it From the Earth to the Moon, where they had a whole episode where they taught the crew of Apollo, I feel like it was 12 or 14, to be geologists. That was how they found the sample of the one that told them, they found the oxygen sample that told them that it was possibly came from the Earth.
Yeah.
And they had
the training they went through was amazing.
Yeah.
Mm-hmm.
Until you wonder, will robots take their jobs?
Yeah.
I guess we'll find out.
Yeah.
Um,
Well, actually kind of bouncing up that a little bit. I'm just gonna answer it and say no. Partly because I think we could we could train a rover to pick up a rock and do a good job of saying, oh, this is what this is.
yeah.
But you still kind of miss out on like the human aspect of just looking up and saying, okay, well, this is the context of where I'm at, and like over here is a stream bed, or over here is an outcrop, or over here is this other feature, and just being able to really quickly put all that together and say, well, this is probably where this came from. Rover, to some degree could probably start to learn to do that,
Yeah.
but just really taking in all those different pieces is going to be hard. So I don't think humans are out of a job for a while, at least.
But it is interesting, right? That here we are 50 years after the astronauts did that first job. And yet if you had to choose between, a fairly capable rover, which was being controlled by people back here on Earth, or an astronaut with a bag,
Yeah.
you'll take an astronaut with a bag.
Yeah. I would. Yeah.
Yeah. Well, so there you go. The astronauts' jobs are secure. So what do you see? What do you hope then, as for the long-term use of the moon, the long-term scientific approach of the moon as we move into the future?
Mm-hmm. Yeah. I guess I'm going to answer from like maybe a personal perspective. I can't necessarily speak for the community as a whole, but there's a lot of interesting things from a long-term scientific perspective. For me, like, and the buzzword you'll hear kind of in the lunar community is like, we need a sustainable presence on the moon. But then there's always the question of like, well, what does that mean? Like, does that mean that we have a habitat and we're living there all the time, or we're coming and going frequently? Like, it can mean a lot of things. What I would like to see is just a continual cadence of missions to the lunar surface. It doesn't necessarily have to be to habitat at the South Pole, but I want to see us going to different places at regular intervals, because there's the South Pole is interesting. There's a lot to do there. It's a great place for humans to live, but there are a lot of other places on the moon that we really need to explore as well. So I think just keeping up the capability, it doesn't have to be all human missions. There can be plenty of there's plenty of sites we can go to and learn what we need to know with rovers, or even static landers that don't move. So just seeing a regular cadence of these missions, both to the near side and the far side, and the poles and humans, and really integrating these things, and honestly, not even just from the U.S. side. We need to have other countries in on it and sharing data, because I get asked often, like, are we in another space race? And no, I mean, yeah, everybody wants to get there, and there's always maybe a little bit of a competitive edge, but really, like, I think everybody's in this to get there and learn stuff. It's a really great chance for countries to work together. So I guess my kind of long-term vision for science is just, the US and these other countries just, going to lots of different places, at frequent intervals, and figuring out, these different questions that, keep arising. We need samples from here, we need samples from there, we need, seismic data from the whole moon. There's just a lot that can be done, by going all over the surface of the moon.
Yeah. I mean, I would love for there to be this time that there is a permanently inhabited scientific base on the moon, in the same way that there is something at Antarctica, in the same way that there is people in the international. I mean, there's been continuously inhabited space station flying above the Earth for 20 years now, which is just a wonderful thought. That you can always go out there and look up into space and know that there have been people in space for this entire time. And it feels important. I mean, we will learn what the long-term value of the moon is in our lives. And it might have no value beyond its scientific value. And just the fact that we are learning to stretch out into space.
Yeah. Live off our planet.
Or we may find that sweet helium-3, and we just grind the whole moon away and to feed our fusion reactors. That sounds like a thing that humans might do as well. So, we've reached the end of our hour. Dr. Watkins, it was great to chat with you today. Thank you so much for explaining. If people want to follow your work, where should they go?
There's a couple. Twitter is a good place to find me. I tweet there. I do have a website that probably needs updated, let's be honest, but I do have one. Or just go to the Planetary Science Institute's website and you can find my name under the staff page, and there's information there about how to find me on different platforms. But yeah, I'd say Twitter or just, my website. Yep.
Wonderful. Well, thank you so much for taking the time to chat with us today. I cannot wait to see what happens next with the moon.
Me either. Thank you. I really enjoyed this.
All right, take care.
All right, bye.